Today's I can statement is I can write numbers using exponents. During this video at any time, I suggest to pause and write notes if you need to. First, we need to start with what is an exponent. An exponent is a number that tells how many times a base number is used as a factor. Now that sounds like a lot, so let's break it down. Let's say I gave you this equation right here, and I said that 1,000 is equal to 10 times 10 times 10, which is also equal to 10 to the third power. So what you see on the right-hand side is actually an exponent. That 3 is an exponent. But first, we start with the base. In this case, our base is 10, and our exponent is 3. The base is the number that we write, and the exponent tells us how many times to write it. So in this example, what they did is they took 10 and they wrote it 3 times. Those are called our factors now. When we write them out, they're called our factors. And if you were to type 10 times 10 times 10 into a calculator, you would get 1,000. When we write all the factors out like we did in the middle with the 10 times 10 times 10, we call that expanded form. When we write it with an exponent, we call it exponential form. So 10 to the third power is an exponential form. And on the left, we just have the number 1,000. And we call that standard form because that's how we typically would say the number. What if I asked you to write all the factors of 10 to the fourth? We would write it like this. 10 times 10 times 10 times 10. What we did is we took that base of 10 and we wrote it out 4 times with multiplication signs in between. So what we just wrote 10 to the fourth and we wrote that in expanded form. What would it look like in standard form? So again, standard form is if we actually did the math and we did 10 times 10 times 10 times 10. In standard form, it would look like just the number 10,000. What if we look at some patterns? So let's see what you notice. Let's start with 10 to the first power. We're going to take 10 to the first power and we want to put it in expanded form. So again, the base is 10, the exponent is 1. The base is what we write and we do it as many times as the exponent tells us. So in this case, we would write the number 10 1 time. And that would give us just 10. Now, if we were to type 10 into the calculator to figure out standard form, we would just get 10 because we're not multiplying it by anything else. If we look at 10 to the second power, we look at the base and the exponent. The base is again 10 and the exponent is 2. So we have to take that 10 and write it 2 times to get the expanded form. So 10 times 10 is our expanded form. If we type that in the calculator to figure out our standard form, we would find out that it's equal to 100. 10 to the third power, again, our base is 10, our exponent is 3, so that tells us to write the number 10 3 times. So 10 times 10 times 10 would be our expanded form. If you type that into the calculator to find standard form, you'd find out that it's 1,000. Our next one is 10 to the fourth power. 10 is our base, 4 is our exponent, and we would take that 10 and make it 4 times. So 10 times 10 times 10 times 10 is our expanded form. In the calculator, it would pop out as 10,000 as our standard form. And the last one we're going to work on is 10 to the fifth power. 10 again is our base and 5 is our exponent. So what we would do is take that 10 and write it out 5 times. So 10 times 10 times 10 times 10 times 10. And if we type that in the calculator to find standard form, it would give us 100,000. So what I want to know is what pattern do you notice with standard form? So that very last answer that we got, so the 10, the 100, 1,000, 10,000, 100,000, what pattern do you notice? If you look, what you should notice is that the amount of zeros in your answer actually match the number the exponent is. So for 10 to the first power, our standard form answer was 10. So it had 1 0. 10 to the second power standard form is 100. 100 has 2 zeros, and it keeps going. What if we added more to our patterns? Let's see what you notice. Our previous patterns for standard form showed us that 10 to the first power is a 1 with 1 0. 10 to the second is a 1 with 2 zeros. 10 to the third is a 1 with 3 zeros, and so on. What happens if we tried to make it a little bit more difficult and I asked you to do 3 times 10 to the first power? Well, in our previous example, we already found out that 10 to the first power is really just 10. So what this problem is actually asking us to do is to just do 3 times 10, which would be 30. On the next one, they want us to figure out what 3 times 10 to the second is. Well, in our previous example, we found out that 10 to the second power is just 100. So all this is asking us is 3 times 100, which would give us 300. The next question wants us to do 3 times 10 to the third power. And if we look in our previous example, we already found out that 10 to the third power is just 1,000. So 3 times 1,000 is 3,000. In the next one, we have 10 to the fourth power. We already found out that 10 to the fourth power is 10,000. So in this question, they want us to do 3 times 10,000, which is 30,000. And the last one is 3 times 10 to the fifth power. We already know 10 to the fifth power is 100,000. And now we have to find out what 3 times 100,000 is. And we would get 300,000. What pattern do you notice now? If you look, it's the same pattern as what we had last time. The amount of zeros in the answers match the number the exponent is. But this time, all we had to do was multiply it by a 3 as well. So that's why the numbers start with the 3. So we get 30, 300, 3,000, 30,000, 300,000. Let's try and do it backwards now. I'm going to show you the expanded form, and we're going to try and write it using an exponent. So what happens if I gave you something that looked like this? 10 times 10 times 10 times 10 times 10. 10 is our factor, and it's written 5 times. So we would write it like this using an exponent. 10 to the fifth power. Again, if you look at that first part where it said 10 times 10 times 10 times 10 times 10, 10 was our base, and it was written 5 times, so we know the exponent needs to be 5. In standard form, it would be a 1 with 5 zeros because that 10 was written 5 times. So a 1 with 5 zeros, which is equal to 100,000. Let's try something a bit harder. I'm going to show you a number. Let's see if we can expand it. The number is 209,340. First, let's start by writing the values of all the non-zero digits. So if we look at the 2 in the number above, the 2 is actually worth 200,000. We know this because the 2 is in the 100,000 spot. The 9 is actually worth 9,000. We know this because the 9 is in the thousands place. The 3 is worth 300 because the 3 is in the hundreds place. And the 4 is worth 40 because the 4 is in the tens place. Now, let's expand those values. The way we had them written before was just in standard form. That's what it looks in standard form. Now we have to expand it out. So a way we could expand this is by saying 200,000 is equal to 2 times 100,000. 9,000 is equal to 9 times 1,000 because the 9 is in the thousands place. 300 is equal to 3 times 100 because the 3 is in the hundreds place. And 40 is equal to 4 times 10 because the 4 is in the tens place. Lastly, we have to take the expanded values and add them together like this. 2 times 100,000 plus 9 times 1,000 plus 3 times 100 plus 4 times 10. That is how it would look in expanded form. I know it looks like a lot, but make sure we sit down and actually look at it. The 2 is in the 100,000 spot, so that's why we do 2 times 100,000. The 9 is in the thousand spot, so that's why we do 9 times 1,000. The 3 is in the 100 spot, so that's where we got the 3 times 100. And the 4 is in the 10 spot, so that's how we got 4 times 10. Now I want you to try. On this form below, question 1 is what is 10 to the 5th power in expanded form? Question 2, what is 10 to the 5th power in standard form? And question 3, what is 4 times 10 to the 5th power? Answer these questions in the form below. I would suggest that you pause this video now because I will not be writing these questions again below. I want to see that you actually watch the video. So again, please make sure to submit your answers below.